Hello, everyone. Today, I will continue to show you Task 1 of Project 5, Temporary Power Safety Technology for Construction Sites. This lesson requires you to master the following points. 1. Classification and safety requirements for distribution lines. 2. Selection of fuses. 3. Temporary power safety technology on construction sites. Let's start with the knowledge about distribution lines. The power distribution lines on construction sites are split into outdoor and indoor lines. There are two common laying methods of outdoor lines: overhead laying of insulated wires and underground laying of insulated cables. There are two common laying methods of indoor distribution lines: open laying and hidden laying of insulated wires and cables. 1. Overhead lines. Overhead lines consist of conductors, insulators, crossarms, and poles. Overhead lines must be insulated copper wires or insulated aluminum wires. The former is preferred. The span between overhead lines must not exceed 35 meters, and the distance between lines must not be less than 0.3 meters. The maximum sag of the overhead lines from the ground shall have a minimum vertical distance of 4 meters in general construction sites, 6 meters above roads for vehicular traffic, and 7.5 meters above railway tracks. For the selection of the cross-section of the conductor, the cross-section of the insulated aluminum wire used for overhead lines shall not be smaller than 16 square millimeters, and the cross-section of the insulated copper wire shall not be smaller than 10 square millimeters. The minimum cross-sectional area of overhead insulated aluminum wire crossing railways, highways, rivers, and power lines within the span shall not be smaller than 35 square millimeters. The cross-sectional area of insulated copper wire shall not be smaller than 16 square millimeters. There shall be no joints within the span. The cross-sectional area between the working zero line and the protective zero line of the three-phase 4-wire system shall not be smaller than 50% of the phase line. Different safety colors should be used for different wires to correctly distinguish the phase line, working zero line, and protective zero line in the wire and avoid maloperation-related accidents. The colors of phase sequence L1A, L2B, and L3C are yellow, green, and red, respectively, while the working zero line N is light blue. The protective zero line PE is a green or yellow dual color line. 2. Cable lines. Cable lines are divided into underground cables and overhead lines. Open laying is prohibited. In comparison to overhead systems, direct underground burial of cables has several benefits, including robust construction, good heat dissipation, increased safety, higher service reliability, fewer chances of faults, low maintenance costs, and less personal harm and interference from outside disturbances like storms, lightning, etc. Therefore, underground cables should be preferred. The safety requirements are as follows. The cables should be laid in places free from the disturbances of any mechanical operations or other thermal radiation and away from buildings and traffic arteries. Rugged armored cables should be used for direct underground burial of cables. Rubber cables should be buried by crossing over a pipeline for protection. The direct burial depth shall not be less than 0.6 meters. Fine sand, no less than 50 millimeters thick, shall be evenly laid above and below the cable to facilitate heat dissipation and adjust deformation, and then covered with a concrete protection board, as shown in Figure 519. Cable covers should be added when cables pass through buildings, structures, and other places to prevent cables that would otherwise be at risk of damage. 6. Fuses. The melt wire in the fuse generally plays the role of short-circuit protection in the circuit. The wire melts and separates in the event of excessive current, protecting electrical equipment and circuits. So, the wire is a good device for protecting electrical equipment. 1. The selection of the types of fuses. Appropriate types of fuses shall be selected depending on the operating environment, load properties, and short-circuit current. 2. The selection of the rated voltage and rated current of fuses. The rated voltage of the fuse must be equal to or greater than the rated voltage of the circuit. The rated current of the fuse must be equal to or greater than the rated current of the installed melt. 7. Temporary power safety technology on construction sites. 1. TNS system. TNS neutral protection system must be used for the power line with a dedicated neutral point directly grounded on the construction site. The figure shows that its neutral line PE and protection line N are separated. 2. Requirements. A. The same earthing electrode system should be used for the same power supply system. B. When the subcontracting unit adopts the power supply of the general contracting unit, the protection method must be consistent with that of the general contracting unit. 3. 3-level distribution and 2-level protection. 1. The 3-level distribution system includes the general, distribution, and switch boxes. 2. 2-level protection requires all electrical equipment on construction sites to be equipped with residual current-operated protective devices and connected to neutral or grounded for protection. 4. Connection to neutral and earthing. A. The working zero electrical equipment is connected to the working zero line due to operational needs and is a necessary circuit for single-phase loads. B. Under normal or fault conditions, to facilitate the safe operation of electrical equipment, there must be one ground return point, usually the neutral point of the transformer. After the neutral point of the transformer is connected to the ground, there is no voltage potential between the neutral and the ground. The neutral point can be called zero potential, and the current of the neutral line is zero, commonly known as the zero line. 3. A protective neutral connection connects non-current carrying metal parts of the electrical equipment to earth under normal conditions. 4. Protective earthing or PE is the connection of all the non-current carrying conductive parts of the electrical equipment under normal operation conditions that may present dangerous ground voltage in case of faults to the ground through a cable conductor to prevent the metal casing from being charged due to insulation damage and prevent such voltage from endangering personal safety. 5. Repeated grounding is a system with which the neutral point is directly grounded, and the ground is reconnected to the earth at one or more places of the zero trunk. That concludes this lesson. Thank you, everyone.